let's continue working with dplyr and performing data transformations. Functions in dplyr are called verbs since functions perform actions and verbs describe actions. There are a number of verbs and you can classify the verb by whether it acts on rows. So you can have verbs or actions or functions that act on the rows of your data frame or table. You can have verbs that act on columns of your table. And the third category is you can have verbs that act on groups that you create using group by. So let's look at all the different verbs that act on rows. We already saw filter, and let's get some more practice with filter. Let's filter the flights dataset to identify flights leaving in the first quarter of the year and determine how many flights departed in the first quarter of the year. And so now we will use the pipe syntax. We start with the flights table and pipe it to filter. Now filter takes logical expressions that act on the column names. So when I start filling out the month, I want the month to be either January or the first month, or I want the month to be February or the second month, or I want the month to be March or the third month. And this would give me, the output of this would be a table that only contains the rows, since filter acts on rows that correspond to flights that flew in January or in February or in March. And now I want to determine how many such flights there are, so I can pipe this to the nrow function. And recall, you can any function that takes a data frame or a table as the first argument, this pipe will work with it, even though nrow is just a regular function. We can pipe to it since nrow's first argument is a data frame. And so now I can run this chunk and I discover that there are 80,789 flights that flew in the first quarter of the year. In situations where we use the equality operator and the OR operator to check whether a variable has one among several values, there is an OR operator that can come in handy. Let's first define first quarter as a vector defining the first 3 months, and then we can set up the same sequence of work, but in filter we will say month %in and a vector of alternative values. And this statement, month in first quarter, will evaluate to true if month has a value that matches one of the values of this vector first quarter. And then we can complete this with nrow, and when we run this code chunk we get the same answer, although this is a much more concise statement than having to repeatedly use the equality and OR operators. Another task in data transformation is to rearrange the rows, to sort them, to find the smallest or the largest of something. For example, we may want to know what is the earliest flight to leave on January 1st, 2013. And the verb or function dplyr provides to rearrange the columns in a certain order is known as arrange. And we'll do this example. We will pipe flights to arrange, and we would want to first sort in the order of the year. It's not really necessary since we have only 1 year here. Then the month, that would put January, flights in January on top, and then day, which would put the 1st of January on top. And then we could sort all the flights leaving on each day in ascending order of the departure time. And we can take this table and pipe it to glimpse to see what the first few rows are. And when we run this code chunk, we see that the flight 1545, United 1545, which left at 5:17 a.m. was the very first flight to leave in the year 2013. If we would like to sort in reverse order or descending order, then we use the desk function. So for example, if we wanted to determine what is the latest flight to arrive on the 1st of January, then we would do the same as before. We'll have flights, pipe it to arrange, and we would want to sort year, month, and day in ascending order, since we still want January 1st to be at the top. However, we would sort the arrival time in descending order since we want the last flight to arrive. And we can pipe this to glimpse, and this shows that the B6 flight 1109 was the last flight to arrive on January 1st, which was at 2400 hours, so just before the day turned to the 2nd of January. It is even possible to sort on some quantity that has been computed based on the values of the variables or columns. For example, let's say we ask the question, are there any flights that arrived early despite leaving late? To find such flights, we could compute the difference between the arrival delay and the departure delay. And if this difference is negative, it means that there were some flights that had smaller arrival delay as compared to their departure delay, which means they made up some time. And the smallest such number will tell us which is the flight that made up most of its departure delay. And let's try and do this. Let's find such flights. So we'll take flights and pipe it to arrange, and here we will give arrival delay minus departure delay, and let's glimpse it, and we can see HA51 that had a negative arrival delay, which despite leaving 60 minutes or 1 hour late, it arrived 27 minutes early. Another type of task is to determine how many distinct values a variable has. For instance, there are many destinations over here, and each destination appears more than once for each time there was a flight to that destination, and we would like to determine how many unique destinations there are. For this, dplyr provides a verb called distinct, and I could pipe flights to distinct and give it the name of a variable or a column, and it will return a data frame which contains all the destinations without repetition. And so now we can pipe this to end row and determine what are the total number of destinations, unique destinations, that there were flights from New York area airports, and that number is 105. One can even determine how many unique combinations of two or more variables there are. For example, if you wanted to determine how many unique origin destination pairs there are in the dataset, then we would pipe flights to distinct and provide it, instead of one variable like before, two variables. And if we just have a glimpse at this, now you see there are two columns in this table which represent origin destination pairs, and we can pipe instead to end row to count how many rows this new table has, which corresponds to the number of unique origin destination pairs. And so there were 224 pairs of airports which had flights between them in this dataset. If we look at this dataset, if we go back and glimpse at this dataset, this has only two columns. All the other columns have been suppressed. Now, if you wanted to have all the columns, then we can use the keep all argument to distinct, and we can set that to true. And upon doing so, we have the origin and destination pairs, but it has retained all the other information as well. All the other information will come from the first instance where it finds a particular origin and destination pair. Now, one thing worth noting is the weird syntax of this argument to distinct, where the argument begins with a period. The reason for this weird syntax is dplyr verbs or functions are special in that they take the variables or the column names of the table as arguments, and in order to distinguish arguments that change the behavior of the functions, that is the regular arguments, you put a period in front of regular arguments, whereas if there is no period in front of it, it is assumed to be the name of a variable or column in the table. Now, here we simply found out how many pairs are there in the table, how many unique pairs of origin and destination pairs. Supposing our question was different, supposing we wanted to know how many times these pairs appeared in the original table, which means how many flights were there between each pair. In that situation, we can use the count function. And let's say we wanted to determine the number of flights in 2013 between each pair of origin and destination, then we could pipe flights to count and give it the origin and destination variables as arguments, which means it will construct all possible pairs of origin and destination. And if you give it the argument sort is equal to true, then it will also sort the origin and destination pairs in descending order of the count. When we do this, we see that the pair JFK and LAX, so John F. Kennedy International Airport and Los Angeles International, had the most flights between them, which is 11,262.